Hi, welcome to my presentation about the CMPT479 final project solution about Peregrine. Let's start with the count application. So the count application originally expects the data graph name, the pattern is supposed to count for, and the number of threads in the local instance. I also added this part, which is not included in the other suggestions for other applications. Essentially, if we were to provide 0 as the last command line argument, it will be a flag to signal to Peregrine that this is a requester. So the pattern that we will be using is 0mq's request reply. Let's move on to Peregrine internal count. If it's a requester, it will set a global flag saying that, okay, this is the requester and it should be treated as so. The requester will know about the total number of tasks and will bind itself to this port right here for message sending purposes. The most important performance results will be recorded here, since the request node starts sending out messages and starts sending out tasks. It is imperative that it starts the performance measurement from the first message being sent out. So it will, for every single pattern in the patterns that were passed to Peregrine's count, it will reset the task starting index to 0. It also knows about the workers that have finished after all of the tasks have been gone through, and record an aggregated result as well. It also knows about the number of connections that will be the number of workers, which is via subscribers expected. In this case is 3. While the the number of tasks is still in range of the total number, it will start sending out it will keep sending out the starting task index to the workers and receive a reply from them. When it receives a reply, it automatically thinks that the workers are ready for more work, and it increments the starting task index by the task batch size. This is a constant. At the moment, it's being set to 100 tasks per worker, but for performance measurement purposes, it was already also applied to 50 or like 200, 500 tasks in a batch. So after all of the tasks have been gone through, it will be sending out end signals. These end signals are imperative, since they signal to the workers that we would want your aggregated results, and we're moving on to the next pattern, or we're ending the execution and we're returning the aggregated result to the users. So when it sends it out, it will be receiving the aggregated result, which is the workers product, from the workers, store that result locally, and wait until all of the workers have acknowledged that they have ended their execution for that single pattern. Afterwards, the aggregated count will be recorded for that particular pattern. After all the patterns have gone through, it will record performance measurement and then close the socket. In the reply nodes, a similar thing happens. It connects to its a listening socket, and it resets the global count for every single pattern. As long as the message received from the requester is not end signal, it will print this for debugging purposes, and also set the task starting index to whatever the message content is. The task counter and the task counter limits will be the bound limits, the bound range that the local threads will be counting the patterns from in its local copy of the data graph. After these two bounds are set, it will begin matching Afterwards, the global count should be incremented to the expected number, and that will send it to the requester. This send is more for acknowledging that I've done my work and are ready for more work purposes. After it sends out, it receives an end signal from the requester, then it receives and then it sends out the aggregated results for that single pattern to the requester, and that will be added in here. It also records its local count for that pattern for debugging purposes. And verifying correctness. This performance is measured, however, it won't be correct since the reply nodes will be started early in this solution. Therefore, these values will be slightly bloated. Then afterwards, it does its cleanup work, clean up all of the local threads, returning the elapsed time and the results. Let's see the context. That same logic will be is implemented to all of the match subtasks as well. So in the match, it will also know about if it being a requester or not, which will be sending out tasks, delegating tasks to its workers, and similar workflow is already implemented in single match vector and match multi. For match multi, for FSM, which is not implemented in this solution, the reason why it's not correct is because when the requester receives a reply from the reply node, it doesn't know which value, which pattern is supposed to record this aggregated result to. So it only knows about the count, but the pattern that it discovered is currently not stored in the requester. That's why the results will be different and will take more time and clarifications to be implemented correctly. But the 0MQ workflow is there. With match single, it is currently working correctly. So the is requester flag will come into play, bind to the same port, and then listen for aggregated results from its workers, and recording the aggregated results for that pattern. It will also be written to the disk as well if output is triggered. Recording the performance, similar thing, waiting for messages, setting the bounds, and sending back acknowledgement for more work, and sending back the aggregated results for that pattern. Do its cleanup work, go through, print all of the debugging messages. The reason why it needs the two bounds is because they will be used in the match loop subtask and the count loop subtask as well. So if the task counter limit is more than the total vertices or in the total of patterns, then it will only set it to the expected last vertex index. If not, it will be set to whatever value that was incremented by the requester when it receives. That same logic is implemented into count loop so that it doesn't go over the bounds, it doesn't count more than it needs to, and return incorrect values. So let's see how it actually performs. in our cluster. So all of the Slurm output files and the Slurm shells will be available. All of the Slurm output files will be available in the root directory of the project. Reason being, it should access the correct executable. Slurm shells will be accessible in the root directory as well. However, in the submitted project, it is under the Slurm shells directory. This is in the directory itself is in the root directory. So all of these files contain the performance measurement. Let's say output.txt. Yeah, so as you can see here, it's currently executing enumerate for query / p7.graph in this particular performance measurement, but the results in the report are also contain results for 3 motives as well, and verified for them. So let's move on to so how we should execute this is having the reply nodes, like let's say reply count, waiting, submitted. This will prompt 3 workers, outputs it here. All of these configurations are reported in the project report. Then we can do request count shell. As we can see, some of these tasks are being failed during implementation, and since fault tolerance was not implemented, they will not be included in here, and they will continuously wait. 1 0. Let's do this batch for apply shell. So if all the requests and the reply coordinates, then we will receive the correct measurements for the single pattern is counting for. These will be written down in results. Some of the challenges that were overcome was setting this workflow up, deciding on the actual direction, and testing the workflow, verifying correctness, which for output is a bit trickier, since I also combined verifying the actual number of patterns being counted, being written to results, and the actual results directory as well. So originally it was during being overwritten by multiple threads and multiple workers and truncated afterwards, so they look a lot smaller than the original Peregrine is. So that was overcome by removing one of the flags, one of the options in pattern matching. I believe it's in output manager. So there is also a helpers file. This helpers file is used for simplifying the sending and the receiving in 0MQ. All of these are the lower level implementation of sending and receiving these messages. Sending more multi-part messages as well. So that's it for the solution for the Peregrine project. Please let me know if there is anything needed for clarification or information. Thank you for listening.